teach you how to find maximum depth of a binary tree. Okay, so basically I've written a recursive code here, very small, very easy. Here this code basically you need to have faith that this thing will give you max depth of the left subtree and this thing will give you max depth of the right subtree. If you get max depth of left subtree, max depth of right subtree, just add one because you need to add root, right? And after that return it. In case your root has become null, so what should be the height of the tree? It will be 0 only, right? So I've written 0 here. Now there is one more solution, binary level order solution, but this solution which I have written here, it's not the most optimal solution. I mean, it's optimal, but it's not the easier one. So what is the easier solution of it? The easier solution of it is, when you are doing level order traversal, first make sure you don't need to store the levels here, just like this I have written. In that time I wasn't aware of that solution, so what I did, I stored one with me just to know that one is the solution, one is the node, sorry, one represents the number of times, one is the level, sorry. So one is level, this is node, this is nodes level. So roots level is 1, you can consider it 0, whatever you want to do. So initially my current level is 1. Okay, so until my queue is not empty, what I will do, I will check for the first element. uh, Means if I have a queue like this, queue can be represented like this. So root, I have root here and its level is 1. So root's left child, I have root here, let's say 1, 2, 3. So if I add 2 and 3, okay, if I add 2, 2 is on second level and 3 is also on the second level. So can I say that I can remove 1? So basically what I can do, what I can say is that you take out the root, then you add its left children, you add its right children. After adding its left and the right children, you need to uh, you don't need to do anything now. Just make sure, just keep a check that whatever level you are on. So I am checking, each time I am checking that okay, this node's level was what. If this node level was same uh, as the current level, this means that we are traveling over the same nodes belonging to the same level, which is, for example, let's say this was level 2. Okay, this was level 2, this was level 1, this was level 3. So this first node, I will use this first node in order to know that okay, so now my current level was 2, but this, when I got this node, its level was 3, its level was 3. So current level is not equal to this node's level, which means that this level's nodes are already traveled. Okay, and this node belongs to the other level. So what I will do, I will change the current level to the level. Okay, I will change current level to the level by adding a 1 to it. I will do level nodes dot clear, because all the nodes belonging to that level should be cleared, right? All the nodes belonging to the, for example, level 2 needs to be cleared. I was having an array, a vector, which was storing nodes of the same level. Once I add all the nodes of the same level, I will simply push back this whole vector to our answer vector. Okay, means basically our answer vector is storing node all the nodes of first level, comma all the nodes of second level, comma all the nodes of third level. Okay, so this node will help me, the first node of the next level or the third level will help me to know that the upper level, level 2, the level just previous level 2 3 is completed. So now I need to clear my answer. I need to edit add this in my answer vector. So I have written here answer dot pushback level nodes, means this complete vector pushback to the answer. After doing that, make this empty. Okay, make this empty. Now also add the current value, current level value, increase it by 1. So now uh, I will be adding all the nodes of this level, the third level or the next level. And now since this was the node which by whose help you got to know that the previous level was completed, uh, you have also removed this node, right? I mean, you haven't added this node right till now to your level. So since it was the first node of the level, I have pushed it here. Okay, after that simply add this nodes children, which are these. uh, yep, just add these nodes children in the queue, and say, and your queue will be, this was actually this was actually answer vector, and your queue was here. Your queue was having all the nodes belonging to the second level, second level, sorry, third level. And now you have to add uh, left and the right child of these nodes, of this node, which is, which will get added here. Okay, in the queue, this is the queue. Then remove this. Okay, now similarly you have to go to the, in the queue, you have removed this. Now your level already had this node. Now you have this will be the front of your queue, right? But this time the current level will be equal to level, since you have already changed it. So you will simply do what? You will simply push it in your level nodes. So this thing will be simply pushed to our level nodes. And after pushing it, push its child also to the queue. So its child also are pushed here. Now same thing you have to do it again, same thing you have to do again. You will remove it. So take this node, remove this node. Now this nodes level, you will see that okay, this level and this level is again same. So simply push this node here, and then push this node's children here, and then again go here. Okay, so this is how you need to do this. So this was one of the solution which I made. Okay, so there is one more solution which is easier to write. What's that solution? That solution doesn't require this thing. I mean, you don't need to keep track of levels. So you will say, oh, we don't need to keep track of the levels, so how will we track the levels? This is the big question. How will we track the level which we are on right now? So I said, see, first your queue had a root only, right? Your first initially your queue had a root only. This is a queue. So I will say remove root. Okay, remove root, add queues children, roots children to the queue. Also add root to your answer vector, and means level order level, and remove it, I mean add it to your answer. After that, if you have added two children, okay, if you have two children of the root, so what is queue size now? Can I say queue size is not 2? I can say that, right? So I will say that, okay, there are only two nodes belonging to the same level. So I will use a for loop. I will basically use a for loop which will be running for how many times? It will be running for q dot size minus 1 times, because I am starting from 0, so I am writing minus 1 times. Basically it's running for q dot size times, q dot size times. Uh, it's getting it, the iteration is being done, and in each iteration I am taking the node, I am adding the children, I am adding its children in the queue, then I am again taking, then that iteration is done. Now take another node, then add its children. So after two iterations you have this, your queue size will be 4. Basically this thing is simple. If you try to do it on your own, just looking at the video will not help, even though you will find some videos which will be teaching you that, uh, in which you don't work yourself and watch the video and think that okay, you understood. So you will not understand it for very long. You have to work like some scientist, okay, then only you will be remembering these topics for very long. So these are the childs. So again this queue will be running for how many times? This time it will be running for 4 times, okay. And in 4 times this will remove, every time it will remove the queue's front element, then add the front element's children in the back of the queue, also in the, I should write here, level nodes I will define here. So this will, so basically what's happening here in this for loop, by the help of this for loop I am traversing over all the nodes belonging to the single level in a single go, so that I don't need to keep track of which node I am on. If I have 4 nodes, so if I use this for loop for 4 times, so in 4 times, every time since I am removing it and I am adding the child, so can I say that after running this loop 4 times, so this will also get cut, this will also get cut, 2, 3, 4. So these all 4 nodes will get cut, will get removed, okay, and after and removed and added to our nodes level, and also their children will be added to the queue, and after that you can simply push back push back these level nodes in your answer dot push back answer dot push back level nodes, okay. So why we were using this for loop? We were using this for loop so that uh, we know that how many nodes are there belonging to the same level in a single queue, such so that we can remove all the nodes belonging to that level, all the nodes belonging to that level, and yeah, all the nodes belonging to that level in a single go, so that so that we don't need to keep track on which level we are on. Just like I told that this for loop will run for the four times. This will remove all the four nodes belonging to the same level. And next time when this will again come here, and next time it will run how many times. This for loop will run number of times when the next level, let's say if root was level 0, this was level 1, this was level 2, then level 3 nodes will be coming, and they will be traveled and removed out, means same things, what uh, what same things we have done for them. So yeah, that is it for the video. Try to write the solution. I will give you this solution. Don't think that I am not giving you this solution, this for loop solution. You try it on your own. You will find this solution in lead code discussion, lead code solution section. Okay, someone who would have written this, and if not also, then I must have written. I will teach you that solution in some other video. Okay, so that's it for this video. I will see you in the next one.